another word for what? When you're looking at a graph, what's a 0 on your graph? Where it crosses the x-axis. Okay, so we can find a 0 like of a line. We could find when a line hits the x-axis. We can do it with a quadratic. We can find x-intercepts. But when I start throwing like x cubes, if I say x cubed plus 3x squared minus 4x plus 6, that's not something we can just do box method and factor and figure out what our zeros were. So we're going to need some new strategies. One thing that we will use is, skip that, in section 3.2 with the synthetic division, one thing that was on that notes handout was the factor theorem. And it's basically telling us that something is a factor if you get 0 for the remainder. Okay, this is using the remainder theorem, which I know a lot of you haven't really been using specifically. But if I said I wanted to take, let's just do x cubed plus 3x squared minus x minus 4. And I want to divide that by x minus 2. So we can do that. We know synthetic division, right? So what would we put out in the box? A 2. And then we put our coefficients. So the 1 comes down. 1 times 2 is 2. Adds to 5. 2 plus 5 is 10. We get 9. 9 times 2 is 18, so we get 14. So, is this a factor? Does it divide evenly? No. All right, I want you to do something for me. Grab a calculator. And I want you to plug 2 into this original polynomial. So, replace all of your x's with 2's. What'd you get? 14. Where did we see 14? The remainder. So what we are going to be concerned with is trying to find things that would divide it evenly. Instead of doing the whole synthetic division every time, we can just plug the 0 for what we're dividing, so plug 2, into the equation. And what we get out is our remainder. Okay, so it's kind of a shortcut if we don't care about the entire synthetic division, just the remainder piece. So if I wanted to decide if x minus 1 is a factor of this function, give me 2 options for how I could do that. Synthetic division. And what should I be looking for a remainder? 0. What's the other option? Plug a 1 in. So which one's going to be faster? Plug the 1 in. All right, so plug in x equals 1. And what'd you get out? C. So, is this a factor? Yeah. Yes, it divides evenly. We divide and we get a remainder of 0, so it works. How would you do B? Like -2 in. Make sure you watch your parentheses when you do that. So put the -2 in parentheses and put the exponent on the outside. What'd you get? -27. So is that one a factor? No. You guys do this one on your own. And what did you get for f of 2? 8. So is it a factor? No. All right. So again, we could be doing all these with synthetic division, but if all I'm asking is, does it go evenly? This is a faster way to get there. All right. So now let's take some information. I am going to give you a polynomial. Do we have any techniques to factor something like this right now? Not really. 4 terms, we could try factoring by grouping, but it doesn't work here. And if grouping works, you really had or grouping didn't work, you didn't have any other options. We are going to figure out how to factor things like this. Today, I'm giving you a starting point. So I'm going to tell you the first 0. So here's your clue. 5 is a 0. So that means x minus 5 divides this thing evenly. Okay? So what we're going to start doing is dividing. If 5 is a 0, we're going to do synthetic division with this 5. Because I am trying to factor this number out. You know, just like if I gave you an actual number, if I said negative, or let's say I just said 30. And I told you to break that down into prime factors. What do? You start finding things that divide it, right? You know it's divisible by 3. And when you take 30 divided by 3, you get 10. So when you found the first one, you divided it to get the other one. So if I know 5 works, I'm going to do the division to figure out the other piece. Okay. So let's do this division. We're just doing our synthetic here. So 6 comes down. So 6 times 5 is 30, plus negative 37 is negative 7. Negative 7 times 5 is negative 35. Add those, we get negative 3, negative 15, and 0. I should get a 0 there. If I didn't, I made a mistake. Why do I know that's going to be a 0? I already told you 5 is a 0. So if you don't get that here, you've made a mistake. This is my remainder, my constant x and x squared. Okay, so if I'm trying to break down 30, I know 3 works, so 30 divided by 3 is 10. And then what do you do with 10? We break that down, and what goes into 10? Okay, so this is like my 10. I have to break that down. Is that something I could break down? Yeah, that's a quadratic, and we can factor quadratics. So you guys like slip and slide. So we get x squared minus 7x minus 18. What multiplies to negative 18 and adds to negative 7? Am I done? No, you started out multiplying by 6. So divide by 6. 9 over 6, what's that reduced to? 3 over 2, so that gives me a 2x minus 3. And 2 over 6 reduces to 1/3, so that's a 3x plus 1. I'm sorry, I know I didn't leave you a ton of space on that handout. Just trying not to use tons of paper. But we're almost there. My directions were to factor this. This was originally x to the 3rd, so how many parentheses should we have? 3. I have 2. What am I missing? 5. 5 is a 0, so what would go in here? And if you multiplied this all out, you would get back the original polynomial. So at this point, the only way we're able to do it is if I give you the first one. Then we can divide it, we can break down our quadratic. And at the end, since 5 is a 0, you have to do x minus 5. If this had been a negative 5, what would I put here? X plus 5. Okay. Alright. Try something ugly. It's not as ugly as it looks though, I promise. So we've done some synthetic divisions with imaginary numbers before. And it was kind of ugly. But you'll notice this original polynomial has i's in it as well. So if I'm giving you k, I'm just giving you the first 0. That's what goes in my box. So my coefficients are my everything except the x's. So we have a 2, we have a 3 minus 2i, we have a negative 8 minus 5i, and we have a 3 plus 3i. Okay, it looks kind of gross at the moment, but we're going to be in good shape because when we do the synthetic, all these i's are going to disappear. So when I bring down my first one, the 2 comes down. When you multiply 2 times 1 plus I, what would that give me? What happens when you add those? So 3 plus 2 is 5. If I distribute my 5 through here, we get those, the 5 i's drop. Negative 8 plus 5 is negative 3. Multiply negative 3 times 1 plus I. And this time everything cancels and we get a 0. That's my remainder, my constant x and x squared. So, what do I do now? Flip and slide. So we get x squared plus 5x minus 6. What would that factor into? Should be positive 6 and negative 1, right? Multiply negative 6 and add positive 5. Then what do we do? Remember in the slip and slide, if we start out multiplying by 2, we have to divide our 2. So 6 divided by 2 is 3. And then we have a 2x minus 1. Okay, so the final factored form, what am I missing? 1 plus I. Okay, so when we had a 5, we just did x minus that. So if I do x minus 1 plus I, what does that become? X minus 1 minus I. You have to run that negative through both pieces. So it looks pretty awful to start with, but it actually wasn't so bad because when we did that synthetic, all the i's disappeared, and then we just had a regular quadratic to deal with. So what I've been doing on the last two problems are finding factored form. When I ask for the factors, that still has x's with it. If I ask for zeros, what are the zeros? Where across the x-axis. So it's just a number. So if x minus 5 is a factor, what's my 0? 5. If 2x minus 3 is a factor, what's the 0? 3x plus 1. Okay, so I might ask you for zeros. It's the same thing. So we have to start out by factoring it. So I want the remaining zeros. And I've given you the first one. So it was an x cubed. How many zeros should we have altogether? 3. I gave you one of them, so we're trying to find the other 2. Because I just said give me the remaining ones. So what do I do with that first 0? Synthetic. And we know it's 0, so we know we should get a remainder of 0, and if we don't, we know we have to go back and check our work. So at this point, I get x squared plus 2x plus 2. What do I do now? We need to get the zeros. We need to factor it. Is there anything that multiplies to 2 and adds to 2? But we've dealt with quadratics. If something doesn't factor nicely, how do you solve it? Quadratic formula. Let's do that. So x equals the opposite of b, so -2, plus or minus the square root of b squared minus 4ac all over 2a. So under my radical, I get 4 minus 8, so that's -4. What is the square root of -4? So I have -2 plus and minus 2i divided by 2. So -2 divided by 2 is -1. 2i divided by 2 is I. I only asked for the remaining zeros, so you don't have to restate the one I originally told you. So the remaining, the other 2, are -1 plus I and -1 minus I. Questions so far? So why don't you guys try B? I know it has i's in it, but from the last one you know that when you do the synthetic division, all those i's are going to cancel out. I'm sorry, if you need another sheet of paper, you can get one out. I really printed this for some of the theorems. The examples are just kind of bonus. So.
I know, I said that is
Yeah, I heard you read it.
I'm concerned right now.
You should be.
Well, see, most of the football players are not that intelligent.
We'll come back to math here. So you did this for your synthetic division, so we get x squared plus 7x plus 12. So I gave you guys a nice one, factors nicely, no quadratic formula needed. And I asked you for the remaining zeros. So you didn't have to give me the factored form here. I had already given you 3i as a 0, so you don't have to list it. If you have x plus 3, what's the 0 for that? If you have x plus 4, your remaining zeros are -3 and -4. Okay. Is that all right with everybody? All right. So I want to take a little bit to kind of set us up for tomorrow. So on all of these, I have given you guys the starting point. I've told you what the first 0 is. But that's not always the case. Sometimes you're starting from scratch and you have to figure out the first 0. So this is kind of the reason I printed these notes for you, is this thing right here. This is the rational zeros theorem. So it says, if we have a polynomial function, didn't we write down a definition like this a couple days ago in our notes handout? So we've seen that before. We know those a's are just coefficients. We know x is a variable and we have powers on them. Okay, here's what's important. All possible zeros will be of the form p over q, where p is a factor of a sub 0, or the constant, and q is a factor of a sub n. or the leading coefficient. So we are going to use this to find the starting point if I don't give you the first 0. And I'd like to do maybe one of those, and then we'll be focusing more on that tomorrow. So we'll do a lot more tomorrow. All right. So let's look at an example and kind of figure out what in the world this is telling us. Here is my polynomial. And on these problems, I am going to kind of break it down and make you tell me several different things. The first thing I'm going to ask for is give me all the possible zeros. Okay, so the possible zeros is everything of the form P over Q, where P is a factor of the constant. What is the constant here? 6. What's a factor? It divides it evenly. So what numbers divide 6 evenly? 2 and 3,
and 6.
1 and 6. Now, could I do like positive 1 and negative 6, or negative 1 and positive 6? They can be positives or negatives, right? They still divide evenly. So when we list these, we're going to put plus and minus on every one of them. So I could take negative 6 and I can divide it by positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6. Any of those numbers, if I divide it by, I do not get a remainder. That's everything that divides negative 6 evenly. Q comes from my leading coefficient. What is every number that could divide 2 evenly? 2 and 1. Now, could they be positives and negatives again? Yeah, because you could do 1 times 2 or negative 1 times negative 2. So again, plus and minus 1, plus and minus 2. All right, then we're going to take that and make our list of possible zeros. So we said everything that could work is of the form P divided by Q. So we are going to divide each of these things, P over Q, so 1 over 1. And again, we can have every positive and negative combination, so everything gets a plus or minus. 1 over 2. You take 2 divided by 1 and get 2. 2 divided by 2 is 1. I already have it, so I don't have to list it again. 3 over 1 is 3. 3 over 2. 6 over 1 is 6. And 6 divided by 2 is 3, and it's already on my list, so I don't need it again. Does everybody understand how I got that list? Now, that is not saying that every one of those numbers is a 0. How many zeros can I have here? 3. These are every number that could be a 0. So how could I find one that does work? Plug them in. What should it equal if it works? 0. All right, let's save ourselves some time first. So we're going to halfway cheat here instead of just plugging everything in. Can you graph this for me? Okay, so here's why I'm not letting you solely rely on the graph, because there are situations where every one of the zeros is a fraction, and it's hard to tell those from the graph. So we're going to use our graph to kind of narrow it down. When you're looking at a graph, what are you looking for? A 0, an x-intercept. So we are wanting one of these numbers that is an x-intercept. So look at that graph. Can you tell me somewhere where it nicely hits the x-axis? -6, -1, did you say? So we've got a couple options here. Does it matter which one I start with? No, I just need one of them. We know there's 3 out there, so you might have any one of those 3, and that's fine. What we're going to do from there is start our synthetic division. I am going to require you to list your possible zeros, so you can't just cheat and go straight to the calculator and narrow it down. So I will ask for this list, but then you can use your calculator to find one that works. So pick whichever one you wanted from there. So if I did -1. How will I know it actually works when I do this? We should get a 0. Alright, so 2 comes down. -2, that gives me 9. Do I make a mistake?
I don't think -1.
I don't think it's -1. I think it's
Positive 1 or -6?
Positive 1 or -6. Okay. So 2. Okay. So that gives me 2x squared plus 13x plus 6. Then how do we finish this? We need to factor it, so slip and slide. X squared plus 13x plus 12. So what's that factor into? Okay, but what do I have to do to that now? So we get x plus 6 and 2x plus 1. I am asking for 2 things on this. I want the factored form and the zeros. What else do I need on my factored form? X minus 1. So my zeros, how do I get that? Set each of these equal to 0. So that would give me a -6, -1/2, and +1. Were all of those on my list of possible zeros to start with? Yes. All right. Questions on that one? So that is where we are stopping today. I do want to give you a few problems. So on page 337, we are ready for